There is plenty in which humanity can take pride. The surrounding area has been tailored to fit our needs, and we already have plans to expand our civilization to other planets once we've outgrown Earth. Being at the top is excellent, but it's easy to forget how small we really are. After all, we all have predisposed mental habits due to our unique neurological makeup. Even though it's one of the best, the human brain has a hard time wrapping its neocortex around some concepts. Despite the fact that we have established a reasonably precise picture of the world, a number of paradoxes suggest that reality may not function in quite the way we expect. What is the Fermi Paradox? The absence of alien life on Earth raises the question of why so few extraordinary things have been discovered. If you are unfamiliar with the Fermi Paradox, here is a brief explanation. Since our planet is not unique in the cosmos, the question naturally arises as to why no one has made contact. The core of the Fermi Paradox is the inquiry, where is everyone? And the absence of extraterrestrial civilizations begs the question, is life on Earth really so exceptional? It has been speculated upon for a long time as to why we appear to be alone in the vastness of the cosmos. However, none have proven entirely persuasive, and many remain perplexed. Why aren't other civilizations sending out probes and desperately seeking for other indications of life if there are so many of them out there, potentially at far more advanced levels than we are? The Great Filter is a potential remedy to this question. It is hypothesized that something intervenes before alien civilizations can advance to the point where they may abandon their planetary system and begin conquering their solar system, or possibly their galaxy. We would see evidence of this in our Milky Way if this were true. We don't know if this is the transition between multicell organisms to species that can utilize tools, or if it's the beginning of the journey to discovering the cosmos. This situation is so intriguing because we can't tell if we are now beyond the Great Filter or if it will happen in the future. It's possible that most organisms don't survive past the single-cell stage, yet we've managed to overcome the initial barrier. Or are we, like other alien civilizations, doomed to annihilate ourselves in some unspecified future conflict or by depleting our resources before we can leave Earth? The answers we seek? Here they are. Or maybe they're just hypotheses anyway. Aliens are just too far away. We may be used to the thought of interstellar travel and interactions with beings from vastly different origins, thanks to science fiction films. Still, a severe barrier is imposed by reality. Even communications cannot move faster than light. Our galaxy has a diameter of over 150,000 light years. And for the past century and a half, we've been sending out radio signals. But that's not enough time for our existence to be picked up by any sensors beyond 100 light years from Earth. The Planetary Society created an image demonstrating how significant our current transmission expansion is in comparison to the size of the Milky Way. Since the speed of light is constant across the universe, this constraint also applies to the prospect of receiving signals from advanced civilizations beyond our own. Only about 1% of the galaxy may have been covered by radio transmissions from different planets, according to a 2016 study that incorporated certain estimated parameters on the distribution of stars in the galaxy and the possible frequency of the existence of life. However, we still have to wait about 1,500 years to have a decent chance of being reached by some alien broadcast. Another thought is that we quite plainly could be too early. The theory that there's a lot of intelligent life in our galaxy has been around for a while, but it wasn't until 1961 that radio astronomer Frank Drake put it in algebraic form. Several attempts have been made to reevaluate the so-called Drake equation, which attempts to estimate this number of civilizations. And the consistent conclusion is that these other species must be abundant. But even if we grant this optimistic view, there are still scientists who point out that estimates like the Drake equation ignore the fact that civilizations are born and die, and that these events need not occur at the exact moment in the life path of the universe. Two astronomers from the Space Telescope Science Institute put the odds of other intelligent life in the cosmos at 92% in 2015. But the bad news is that 92% of planets like ours in the history of the universe have not yet formed. We can infer that the emergence of humanity has occurred far too soon, and that we will not be around when other intelligent entities arise. Furthermore, a specific hypothesis suggests that the fact that we have arrived first could prevent the emergence of anyone else, should it turn out that the growth of civilization tends to remove others unwittingly. People who think the universe is brimming with life around which we know nothing are naturally drawn to ideas like the ones discussed before. Yet this does not stop researchers from experimenting with novel approaches. Aestivation is the concept that a superintelligent society might be waiting for the cooling effects of the universe's accelerating expansion to improve the speed and accuracy of its computations. Another theory holds that aliens like us send spacecraft to Mars only when it is closer to Earth, taking advantage of the relative motions of stars. Thus, it's possible that they came to Earth 10 million years ago and won't return for a very long time. All in all, there still isn't a concrete solution to the Fermi Paradox. It does really make you wonder though, where is everyone hiding at? And are we truly alone in this vast expansive universe?